Problem 11. NASA's Perseverance rover was launched on July 30th, 2020. After traveling that many miles, it landed on Mars about 6.5 months later. Which of the following is the closest to the rover's average interplanetary speed in miles per hour? So to find the average speed, we must know a universal physics formula, which is the distance is equal to the velocity times time. Now, in this situation, we're trying to find velocity. So velocity is equal to distance divided by time. If you did not know this formula, then you would not have been able to solve this question. So in the future, make sure you memorize this formula because, trust me, this is going to show up again on AMC 10 and AMC 12 and etc. So V is D divided by T. Now, the distance is 292,526,838 miles. And the time is 6.5 months. Right? But the problem is, or not months. Problem is the units are not correct because we're trying to do this in miles per hour. So don't forget to look at units. Always write units. Units saves lives. So in 1 month, right, or I keep saying month, so I'll just do 1M. 1 month has, well, it's July 30th, right? Well, 6.5 months. So in 1 month, there's roughly 30 days. Right, roughly. It doesn't really matter. You can say 31, but it's roughly 30 days. And for these 30 days, how many days are in an hour? Well, or how many hours are in a day? There's 24. So 30 times 24 will be the number of hours. So that's equal to roughly 720 hours. So in other words, we have 720 hours per month, but multiply that by 6.5 will get you the number of hours in 6.5 months. So this is 72 times 65, which is 36, and then 43, so 4680. So in other words, we're trying to do 292,526,838 divided by 4680. So now it's just being very careful when you divide things out. So before we do this, we could simplify this, right? We could divide by 2. So divide by 2, that's 2340. Divided by 2 here is 1462419, and this divided by 2340, and I'm not going to try to simplify it, I'm just going to divide it out. So 263419 divided by 2340. Now we can't go here, you gotta go continue. This is the starting amount. So let's try to do 7, but if we do 7, that would be 2, 3, 4, so that would be roughly 16,000 something, and that would be too big. So let's do a 6. Well, that would be 13,000 something, and that would work because that's within a 14,000 boundary. So we could do 6, and that's 0, 4, 0, 2, and then 1, 4, right? Or no, 1, 3, because no, that's carry of 2, so that should be a 4. Yep, 14,000. So this should be 6, 8, 5. So 586, and then 586 bring down the 3. We can only do a 2 here, so we could do 0, 8, 6, and then 4. So that's 3, 8, 1, 1. And then we have to bring down the. We brought down the 3, so we must bring down the 4. Right? So yeah, we bring down the 4. Am I doing this right? Because if we scroll back, right? Okay, we're doing this right, so we could continue. So that's 4. Could we do a 5? We could do a 5. So we could do a 5 right here. So that's 0, 2, 7, and then 1, 1. So that's 4, 1, 1. And then we bring down the 1, which gets here, but we can't put anything here, so then we have to put a 9 here. So we could do a 5, right? And when we put down the 5, we got 11720. So we actually can't. So that would be 4 something. So our answer would be 62,504. What is the number that's closest to that number? Well, 62504 would be closest to 60,000, so that's your answer.